Hello, everyone, and welcome to Biohackers Lab. I'm your host, Gary Kerwin, and on today's episode, I have Tim Spector. Tim is a professor of genetic epidemiology and director of the TwinsUK Registry at King's College in London. He is also the author of several science books, including The Diet Myth, The Real Science Behind What We Eat, and his forthcoming book called Spoon-Fed. Tim, thank you so much for coming on for an episode for today.
Pleasure.
So,
looking forward to it.
Yeah, so we're going to be speaking, you're going to be speaking, I'm just going to be at the event, but you're going to be at the Biohacking Congress in February next month. We're in January at the moment. So I'm looking forward to getting to meet you in person and listen to your talk there. But today I wanted to get into your studies and, your profession, which is genetics, the microbiome and food and the relationship between those two things. So my first question for you is, with your last published book, which was The Diet Myth, what did you mean by the word or the phrase the diet myth?
It was a suitably vague term to encompass all of the problems that we've got in really understanding diets and many of the myths and false beliefs around them. And so starting to piece together the problems that we've had with our failure to effectively diet, despite consistent advice for the last 30 years about calories and reducing fat and exercising more, and putting into place why that advice has failed, and basically trying to bring all those elements together with the new science behind this new organ in our bodies, the gut microbiome, which is a way of explaining why we've got it so wrong, because we've really underestimated the complexity of food and our whole body's metabolism. And so we've just been focusing really a little bit on genetics in the past and these calories and macronutrients, and treating it a bit like just a pure energy thing, without really going into detail about the complexity of foods and how they interact with our body and how they interact with these gut microbes, which is very much a cutting-edge new science. And so it was, coming up with one word to describe that complexity was very difficult. But the diet myths seem to work because, I think most people can associate with the fact that 99% of diets fail, and therefore, in a way, just that the word diet is a myth itself, really. In terms, we shouldn't be doing these short-term dieting things, because long-term they are a myth. They just don't work.
Mm-hmm. Yeah, and I think you encompass that quite well, because this whole program is all about individuality, biohacking, N equals 1 kind of stuff. And I think we have guidelines, but as it sounds like, even when it comes to our relationship with food and, if it makes us gain weight or lose weight, it sounds like there's an individuality according to our microbiome or our genetics too, that brings a big influence into this factor.
Yes, and I for the last 25 years, I've been working with these 13,000 twins in our registry, and been fascinated by how similar or dissimilar identical twins are, and nature v nurture. And as time has gone on, I've been more interested in the differences between identical twins, because they're genetic clones, and so they should be pretty much identical for everything. And they're 100% identical for their genes in every cell of their body. And it turns out their microbes are really not that similar. And that probably explains why they don't die of the same diseases. They obviously, environment has a role, but if your genes are identical, then something else had to be going on. And I think that was, for me, one of the big sort of discoveries of the last 5 years, was seeing this difference in identical twins could explain why they rarely both get the same cancer, they both don't die at the same time. Autoimmune diseases are really quite rare in both of them. Things that didn't sort of fit with the standard paradigm of, once we've understood this, then it's all going to be simple. And I think the underlying importance. Genes are undoubtedly important, and as a geneticist, I'm not going to knock genes too much, and they really account for 50% of just about everything in our makeup and even behaviors and other things. But I think we've perhaps overestimated the power of genetics at an individual level. So at a population level, it's fine, and you can do these genetic tests, which we can find genes for all kinds of things, whether it's how long you can exercise, or whether you can process coffee well, or how long you sleep. But actually converting that into an individual prediction has proven to be pretty impossible. And a lot of companies out there are misleading people because they're taking the population result and trying to give it to an individual where it really doesn't work at all. And so with this background of, yes, genetic genes are important, perhaps 50% of what's going on, I was interested to see, well, what about microbes? And the other, when you compare two people, we generally share about 99.6% of our DNA. And we're all are roughly fifth cousins. But if you go to our gut microbes, we're only sharing, on average, around a quarter of our gut microbes with each other. And identical twins only share slightly more than that. They share about 30%. So clearly, we're seeing these vast differences. And if we believe in the power of the microbiome, then that explains this individuality that we have in our responses to the environment, even if we've got the same genes. So in people who aren't identical twins, obviously you've got some genetic differences which will affect both behaviors and how your body works. And then at a second level, you've got these thousands of genes that are contained in the gut microbes that are, in response to that, it can produce all kinds of different chemicals. So to put it in context, we have around 23,000 human genes, and we think there is somewhere between 100 and 200 times more microbial genes that are really sitting there like a sort of extra power pack in our guts, able to, at will, produce different chemical proteins, hormones, vitamins, messengers for the brain, for the immune system, and allow us to digest food in different ways and make us hungry or depressed or sad. So it's this treasure trove of other genes we've got there, like an accessory pouch that gives us this amazing individuality. And that's really what my research has been focusing on in the last couple of years, teasing out this differences between people. And moving away from the idea that most science, particularly in the field of nutrition, has focused on averages. Been obsessed with guidelines. We're obsessed with rules that the average female needs 2,000 calories, the average male 2,500, and that we should have X units of alcohol every day, and that we do, 30 minutes of exercise, and we should have exactly this percentage of fat, and we should have no more than 10% saturated fat, and it's complete nonsense. It's just there really to make governments feel that they're doing something, that they've got a plan, and they can set some nutrition guidelines, which were there really since the war to stop people falling off the other end of nutritional deficiencies. So that's why we had this whole history of being told what to eat, was really after the war, when there was a lot of vitamin deficiency in many countries in the world. And these were the sort of minimum amounts to get children to adulthood and to stop people getting all kinds of deficiency diseases. And we're stuck with this mentality that's in fact making us fat, because nobody is really conforms to these average guidelines. And when you think about these sort of nutritional guidelines that are passed out, you wouldn't have one type of car seat or shoe that all males and all females were told to use. Just at the basic, physical side, it wouldn't be comfortable for us. Hardly anyone would fit this perfect average measurement. And so that's what we've been asked to do with nutrition, particularly, and it's been a disaster. And people have failed to look in it. And it's only really the last year or two, really, that I think people are starting to wake up to think that when you look in trials, you do see much more when you look at individual responses than you do look at the averages. But I'm preaching to the converted here that the power of the individual. But this is very much where my research is going, and of course, this is since writing the book. We've actually gone out and done some of these intervention studies in the twins now, using diet.
Yeah, and that's fascinating. Just because what you're saying there too, I can only imagine the difficulties now where we have these guidelines, but then how do we get to the individual level there at a mass population control? I mean, are we gonna? I'm just thinking in the UK, is a GP going to have a simple test that they could give you and say, "Hey, it looks like you're on this track, so watch out," or I don't know. Do you think they're going to be able to help people at that level, or is it?
Well, I think, a good example. I think one of the best recent examples of a trial that showed this is the Diet Fit study, which was one of the largest randomized controlled trials done of overweight Americans. 609 Californians took part in this study, and they were given a healthy diet to start with. So what most of these other things haven't done is they give them plenty of fruits and vegetables, made sure they had plenty of fiber, reasonably balanced advice that everyone would agree with. And then they were allocated to be either a low-fat diet or a low-carb diet for a year. And this was supposed to solve all this big debate. And after a year, the results were a draw. There was no difference between the two groups. And so a lot of people were very upset on both camps who wanted a clear result. But when you look at the individual data, and that's what we're doing now with the authors of that study, Christopher Gardner in Stanford, you see huge differences within each arm. So some people lost 25 kilos in weight in a year. Other people gained 10 kilos. And that was this, didn't matter which group they were in, whether they'd been allocated the fat or they'd been allocated the carbs. So if you reversed those, you'd get amazing results for probably both types of regime, because it's clear that some people process fats much better than they do carbs, and vice versa. And so the key is, can you come up with some simple test that would, once you've given someone a basic healthy advice, can then point them in the direction of saying, well, you know what, you should be having yogurt for breakfast, or no, you should be having muesli. Something very simple like that over years can make a huge difference to everybody. So that's what we're trying to do, and we've been teaming up with a startup company called Zoe that funded this PREDICT study, the largest interventional study, nutrition study done so far in the world, where we're taking 1,000 people from the UK and 1,000 people in the US, and most of the UK ones are twins. And we've just finished analyzing the UK arm of this, and it should be out published soon. Basically showing, firstly, eightfold variation when people were given a standard meal. in their glucose, their insulin, and their blood fats. So, that's for a start. Wow, I was pretty blown away by that fact that normal people, when you're given a standard muffin, will have this huge rises in some people and really flat lines in others, meaning some people are having a lot of metabolic stress when they're having that meal, others nothing at all. And we know that if you magnify that out to several years, you see differences in weight gain, diabetes, heart disease. And so our aim is to get thousands of people doing these experiments where they have these standardized meals, and we relate that to their baseline bloods and their gut microbes at the beginning. And we put these into algorithms, machine learning algorithms, and you come up with a prediction model for everybody that will say, based on this, we can give you a score for your blood fats, your how you respond to sugars, and the state of your gut microbiome. And we can now give you, through an app on your phone, give you your food scores. So you can look up any food, you can barcode it, and you can say, okay, this is 60% good for me, but that beats this one at 30%, which might be very different for you. And so the idea is that people will get a general idea about whether they should be eating more fats or more carbs. And then if they want to, they can get more specific, personalized advice through an app. And the idea, what we'd like is that millions of people use this. And whilst other people are also developing other quicker tests that, as you said, could be done just by the GP. But I think food is such a complex and common event that I think we have to take this into our own hands. I don't think GPs and the medical profession, A, know enough about it, and B, there are enough of them with enough time to advise people. So I think this is something that really has got to go direct to consumer first, and people will, as they're doing with many internet tests, they're downloading apps, health advice on exercise, Fitbit. I see it really more like that than being totally driven by the medical profession. Partly because the medical profession is extremely poorly equipped to deal with this. As a medic, I can say how badly I was taught and how my colleagues are taught and how they still lack any basic knowledge about nutrition, just having had a couple of hours at medical school 20 years before. Mm. So I think people have got to get the information themselves. They've got to learn about how important food is, the complexity of it, and in a way do their own experiments. And I think that's the crucial thing, not be led by somebody who say, listen, this is the standard meal that if everyone eats, they'll be healthy and skinny. That ain't going to work ever. There is some general advice. It's not saying throw out all advice. Nobody's advising ultra processed foods, apart from the food manufacturers. We all need more fiber. We need more plants and vegetables. We need to snack less. But once you've done that, then some form of a self-experimentation to work out what suits you. Also, the other fascinating thing of the PREDICT study is that we were able to compare the influence of genetics versus the influence of the gut microbes and other factors about the individual. And it turns out that genetics are really they affect about 30% of your sugar responses, which you'd sort of expect from the data on diabetes and obesity, which was slightly more than the microbiome. But individual factors were actually a larger component of it than just genetics, so non-genetic things related to the individual. And when we got to fats, we saw a completely different picture. Basically, genetics had nothing to do with how quickly you broke down the fats in your blood after you'd had a fatty meal. And which is strange because we know that genetics are important in what the blood levels are, but that's long term. But short term, these fatty responses, which can cause inflammation and heart disease, if these bits of fat are hanging around for 6 hours after a meal, which in some people they were, and other people they were cleared immediately. Microbes are really important in that, and whether you had the right set of microbes or not made a huge difference to whether that you could dispose of that amount of fat easily or not. And that was really exciting. But the other exciting bit was also these areas which no one's really touched is circadian rhythms, time of day, what you had as your previous meal, how long you've been fasting for, and other sort of bits about the person we don't yet know. But I think how you eat might be also as important as what you eat. So all these components together make up how we respond to food, which is entirely individualistic and totally explains these 8-fold differences in food responses in normal people. So, but I'm really optimistic, because if everything was genetic, we wouldn't be able to do anything about it. Just sit at home, get fat, and blame our parents. So the fact that we can manipulate, we can determine things like, is it best to have my breakfast, early in the morning, near lunch, or not at all, or should I, my circadian rhythm means I should be eating most of my calories later or earlier. The fact that we can use diet to manipulate our microbes is also, really optimistic. So I think what we're finding out is great.
Yeah. And so it sounds like it kind of looks like we'd have to stack lots of different results potentially here. So have a genetic test as a base, then you might do a microbiome test. I don't know if there's any value in that. And then you might stack on some lab results. So you'd look at your different bloods and whatever, and you collate that all together. And maybe even add in some real-time data like a continuous glucose meter or something else. Mm-hmm. And then subjective things is just how do you feel, or do you notice any other change in symptoms? And you kind of need to put all of that together to truly know what works best for you.
Yes, well, that's what we've done in these studies of these 2,000 people. So they had glucose monitors for 2 weeks. They were pricking their fingers for fats every few days. We had exercise monitors. We had sleep monitors. They were logging all their foods every hour through the app. And then we had all these baseline bloods, and they had a day in the hospital where we collected all the bloods after these standard meals where they couldn't move or anything. So we got the most information we could possible on these individuals, including their genetics as well, and the fact they were twins. We were able to look at the effect of nature v nurture. So, and then the question is, well, that's in a sort of experimental situation, because you couldn't afford to do that on everybody in the world. So now we're piloting this, the home version of it. So you see, well, how well do we do just by sending the kits and the standard muffins to people at home with the glucose, and see if they can, put all these digital wearables on themselves and log their food without actually seeing anyone physically, and that seems to be working very well. And they do have to get a blood test and send it off, and the stool sample and send that off, but you can do it all from home. So I think as you said, there's various levels of this. And what we're trying to see is, what is the most crucial information that isn't so expensive that no one will be able to afford to do it? How can we compress this into something that nearly everybody can do? And the idea is that we've got these different levels of things, and the first thing that we're going to run out in the US in about a month's time is a free app. So people will be able to download the app, put in blood results they might have already, because most people in the US are getting regular health checks, and everyone loves to measure your cholesterol in the US and other parameters. So you put those in, and your blood sugar. You put those into the model and other bits about yourself, and it will give you a rough personalization, because you can use your results with the thousands of people we've already collected to get a rough idea without spending any money. And we want people to play with that and feedback on that sort of beta version. And then as you get more tests or spend more money, then you get a better accuracy. Because as you've said, the more things you put in the model, the more you're going to be able to predict how you will respond to all these different foods. And I think it's not something that's going to be solved ever. I don't think it's going to be evolving. So what we're doing is we're setting up a system that the more data we get, the better it will be for everybody, and the more complex the meals will be able to sort out. Which is going to be tough when you're only up to 10,000 people to sort out very complicated mixed food meals that someone would have with beers and other things. How do you work that out? But once you get to 1 million people, that should be very easily solvable. So it's all scalable, really. And if everyone is happy, and the model we're using with the predict studies is that everybody is happy to contribute their data to these algorithms that can be used to inform everybody. So although you get your own personalized results which aren't of use to anyone else, you're getting the variation and how everyone, their microbes relate to their food and their glucose levels, etc., or their fat levels. That's really important. So, we're just at the start of a big voyage, if you like. But this idea that we're trying to build a community of citizen scientists that will help the community, but actually get something unusually get something that's personal to them, I think it is quite an exciting concept. Because you do have to input a bit of time and energy to get decent results for yourself. Logging food is not simple, even if you've got the best app in the world. Some of this is quite hard work. So, but I'm sure a lot of the viewers here will be exactly the sort of people that would be keen to find out more about themselves and see, and so the first 1,000 people we're giving the results to are very excited because and they like doing the studies because of this feeling that the results will be very specific to them. It's not just a general trial. Yes, it worked. No, it didn't. The idea is that this individualization, and I think this is a really good model going forward of many things we might be doing in medicine, as well as health and well-being.
Yeah, and I think especially in healthcare, it's always the patient wants to be heard and feel that they're being heard. And in this case here, if they go, I think I eat this, and I think it's causing my inflammation, sort of like the gut feel as a pun intended, that it's these, this it sounds exciting when the science is coming out to validate that yes or no, like actually your subjective feeling, your gut feel that this is a problem for you, we can actually try to zone that in and tell you a little bit more definitively, yes, you are on the right track, or no, don't worry about it. So it sounds very exciting.
And people like to compare themselves as well to see how they are on, how are they ranking? And obviously nearly everyone can always do better. Very few people have perfect microbes, perfect, sugar and perfect fat responses. So, and also, with age, so, you may have to retest yourself because, you may be fine at 30, but realizing you may have a potential problem when you're 50, when all these diseases start to happen. That's also useful to know. So it's super fun. So we're excited. Every time we look at this, we've got so much data from this one study that it really would last a lifetime. We've already got about 100 scientists working on this data. Just to give you a few other things that we're finding. Some people complain of having sugar dips. Have you heard of this idea that you sort of, some people quite say they're sensitive to carbs, or either because they haven't had any and they feel like, desperate for a biscuit at 11 o'clock in the morning, which is a very British type of problem. I don't know about South Africa, but I guess it's probably similar, that this morning, something with your morning coffee, you had to have something, which you don't get in the rest of Europe, by the way. It's very much a cultural thing. But other people who might have a carb and then get a little high, and then just after it, they get a dip and they get an energy dip. We thought this was nonsense. I did anyway. But we started to see this with people in their glucose monitors. They went below baseline. And we're getting some preliminary evidence that actually these people have increased appetite afterwards. And so if you can work out, who the person is who's dipping, then really, you really want to avoid those snacks, because they're going to A, make you feel bad, and B, actually make you eat more. So I think we're finding out things that are going to be fascinating for many people. So they might have perfect scores, but some of these little tricks, about when you should be eating, and the intervals between eating, I think it's all going to link in with this new idea of restricted time eating, and not doing as we were told. All of us were told grazing is the best way, avoid gorging. And it's looking increasingly like that. For most people, that's nonsense. But it might be specifically important for some people and not others. So.
And I see that too with the trend in what's called OMAD. I don't know if you come across that, 1 meal a day eating, where people they say that they feel much better if they just have that one big meal a day versus multiple meals in a day.
Yeah, well, generally, our ancestors were probably more like that. It would certainly be one or two. The concept of these 3 meals a day is quite recent, but actually in the UK and the US, most people have 5 meals a day or 6, because they are told to have healthy snacks, eat regularly. So the body just doesn't get a chance to rest. And I think the latest data are, about, say, skipping breakfast are really coming out in favor that it certainly doesn't do any harm, as we were told in the past, and actually some people will benefit and lose weight. And part of that is not just the calories, but the fact that your system is in a fasting state, and actually metabolically that's better. And we now know that it's probably also helping your gut microbes, that the longer you give them to rest, the more the sort of cleanup team of microbes come out at night and help you out. So, some of these illusory bits of science are starting to come together. But it's a time when lots of old ideas are being thrown out, and some of the ones which would have appeared wacky, like eating once a day, people have completely laughed at you a year ago, 5 years ago. Now sort of starting to say, there could be a scientific basis for that. I think it's a bit extreme myself, but I think as a concept, it could well suit some people.
And then and then the same thing with fasting too, because I've seen that particularly in California, where it's there's a lot of the science writers out there in the magazines. They go, "Oh, is this crazy thing called it's intermittent fasting, and are people just starving themselves, and it's eating disorder instead?" But then there's people say, "No, I don't have an eating disorder. I actually just feel so much better when I follow a certain eating schedule."
Yeah, and I've tried most of these things myself, and I have no real need to lose weight anymore. I did lose about 10 kilos since starting to research this about 10 years ago. When I first started researching for the diet myth and understanding about microbes and health and whatever. But now I will just feel like, skipping breakfast, having an extended fast, and sometimes I've just carried it on until the evening. And I do actually feel better for it. I mean, I've got to pick the day I do it, because you've got to be busy. You don't want to be sitting at home next to the fridge when you do it. But there is a certain buzz, and it's also psychologically really important to realize that you don't die if occasionally you don't eat for a fair period of time, because basically nearly every culture and religion in the world has had strict fasting rules, and I think they did it not just for religion, but it does bind people together, makes them feel better, and also the idea that psychologically trains you to not be obsessed with needing your biscuit at 11 o'clock or your healthy granola bar or whatever it is. You realize that, oh, I survived. It's amazing, and yes, you learn to, well, this is a bit of hunger, but actually it didn't kill me, and you go through it. So I'm not into excessive fasting. Definitely don't want to get people crazy about this. Just if people want to do it, just start with skipping breakfast. Nothing more than that. But yeah, this whole this modern idea that we should be snacking regularly, and there's such a thing as a healthy snack, really nonsense. Because every time you're eating it, you're getting some little metabolic stress in your body, whether it's the insulin, whether it's the fats. I spent time with the Hadza tribe in Tanzania a couple of years ago, and they're the last of the hunter-gatherers in Africa, and probably were living the life that we were living 100,000 years ago. And I tell you, none of them was leaping up and cooking breakfast in the morning. They finished eating at about 7 at night, and they would never eat anything before about 10 and 11 o'clock the next morning. And breakfast, they didn't have a word for breakfast. So I think it really is a modern concept, and we have to start rethinking it. Hey, I love breakfast, sometimes, and I wouldn't do without it. But many people don't, and I think again this is part of this individuality. Mm-hmm. And we just need to perhaps listen to our bodies more and not some government guidelines.
Mm. And it's interesting that too, because I'm just thinking now, outside of just what you're saying there with the metabolic response, with the hormonal response, with insulin as an example, but how we could there's this other third party again, the microbiome, and how that gets influenced with what we're doing here. And so the change, even maybe it's thinking of this other person saying, well, if I fast, it does this to them and they do this to me. And that's the benefit I'm getting out of this, or the detriment.
Yes.
Yeah.
So that they haven't done sufficient studies in humans on fasting and the microbiome, but there's quite a lot of animal work being done. And they also show the microbes, like us, have a circadian rhythm. So virtually all forms of life have a circadian rhythm, and in a way, this means there are resting periods and there are periods of activity. And we know that when we don't eat overnight, a lot of our microbes that are responsible for eating food disappear or die off, and other ones come out at night that feed off the mucus, the sugary mucus in the lining of our gut. And these microbes like Akkermansia, and increasingly they seem to be important in our health. And that, far from being flesh-eating microbes, which they are, I mean, they nibble away at our mucus, and that tidies up the gut lining. And we think this stabilizes the community very much. So it's like, it's like if you never leave your desk, it can never be cleaned up. It becomes over time a mess. And if you have clear periods, it can be tied up and clean and much more efficient. And that's really what we think is happening here. But if you're constantly snacking every 3 hours, your gut just doesn't get a chance to recover, and we don't seem to get that good community of microbes. So I think, the idea that the old idea that fasting was all about releasing some hormones or brain chemicals, and I think it's a bit too simplistic. It's very much a complex arrangement that involves definitely the gut microbiome. which are probably the main drivers of all these things.
Mm-hmm. And I can think of another example here where I was just reading a Scientific American article about metformin for type 2 diabetes and how actually the efficiency of that is related to your microbiome. So they found that the metformin influences your microbiome. And it's again, and they mentioned some other drugs there and how some other drugs actually were inefficient because of the microbiome eating the sugar on the drug. And so they've had to modify it to create the efficiencies. But it just brings this level of complexity into it. It's amazing.
Yeah. So there have been some studies showing that at least half of the drugs tested are influenced by our gut microbes. So, we've always assumed that, you take a painkiller, and some people said, "Oh, I prefer paracetamol, Tylenol to aspirin," and others say, "Oh, no, it doesn't work for me at all." Well, it's highly likely it's your gut microbes that are converting one to the active form in some people and not in others. They're probably responsible for the effects of caffeine. To microbes, it doesn't matter whether it's a pharmaceutical chemical or it's one of the hundreds of chemicals in foods, whether it's in a banana or, they just treat them all the same. And they will try and break it down into nutrients and use it in some way. They're this giant recycling place. And so, antidepressants are another really good example where responses are highly variable between people. And some people just get no benefit at all from antidepressants. Others it affects them a lot and they get sleepy or they get a lot of side effects. And by manipulating the gut microbes, you can totally alter those influences. There's some great life or death examples at the moment where we're running a trial of immunotherapy in metastatic melanoma at the moment. And it's using these new immunotherapy drugs, which have revolutionized what was a totally fatal condition to have metastases in melanoma into getting response rates of up to 50%. But depending on what your gut microbes are like at the beginning of the chemotherapy, you have a fourfold chance of living or dying. So, and that's not because the microbes interact with the tumor at all, but they interact with the drug, the immunotherapy drug, to allow it to work and be effective. And we're probably going to end up soon having everyone with cancer having fecal poo transplants or getting tested at least to maximize their ability of their body to deal with the drugs that can then kill off the cancer. So, that's the extreme example, but then you go to the other end, the chemicals in food or artificial sweeteners or just a painkiller or, whether you get addicted to opiates. It starts to open up all these amazing explanations for the idiosyncrasies of humans. And all of them are modifiable. So it's actually fantastic. And, this is why it's, I think, the most exciting thing in medicine and science at the moment.
And I can especially think in cancer situations where, in one way, the patient feels disempowered because they got cancer and they have to go through this treatment. And it's, chemotherapy, radiation therapy is a big blunt tool in one essence still. But in this way, to actually know that there's potential to zone in even better and say, right, something as simple as your microbiome might not make it as efficient, this treatment. Let's do a protocol to boost that, to allow the chemotherapy to work even more efficiently in this case. I think that's very exciting.
Yeah. I mean, already a lot of places in the US in cancer centers are getting people to give a stool sample before they start treatment, and then, because the treatment will often kill it off, they use antibiotics and other things for example, antibiotics are completely fatal if you've got having immunotherapy. So that tells you something about the importance of the microbes. So it's becoming a standard of care to give a sample, and so all of us in the future are probably going to when we're feeling healthy, freeze a bit of our microbes, so we at least get our own ones back when we need them, rather than someone else's we don't trust.
Oh wow! So it's a stool bank.
Yes. No, they already exist, but I think they're going to get more widespread. So, women are now storing eggs. You can get your, embryonic still stored. So, what we need to do is pick the perfect moment when you've got your maximal microbes and store them somewhere in a freezer.
Yeah. So I'd like to just bring it back when you were talking about with your twins earlier, and how they can be so diverse. So they say, it's not a genetic thing; it's a microbiome thing. When do you think that split occurs? Is it from day one, from when they're born? They have the same genetics, they just don't have the same microbial influence from the day they're born, even though they came out at the same time.
The microbiome is different to genetics in that in genetics you can get slight epigenetic changes that slightly tweak it, the function of the genes. But for the microbes, it's very chaotic. The first 3 years of life, our microbiomes are all over the place. They're not stable. Every time you get a cold, they can change. Introduce new foods, they totally change. And what we're seeing is in all kids, whether twins or not, a very unstable microbiome. And obviously, we think a lot of it is the influence of the mother and the environment, but a lot of it is these random effects that happen in early life to all of us. And even when you got two twins, the one who gets the viral infection first can have a very different effect to the one who gets it a week later. So we think that's just these random effects that are happening that, in a way, outweigh the subtle genetic effects, because there are still some genetic effects there. We know that some microbes will like some people more than others, and some of them might be important in human health that we've discovered. But on average, the genetic component is really small compared to the environmental one. So I think there's a lot of hit and miss going on, but the twin model does show us how much it is luck, really, that as we're growing up, even when you come from the same, born within an hour of someone else, you're going to have very different microbes. These life events. It might just be which food you had first. Were you given the bottle first or second? Sitting in a different class at school. Did you get an antibiotic? We think antibiotics are really important, and it's very hard to find any young adults who haven't been given antibiotics in the modern age. And the exact timing of it, these also make a difference to your gut microbes.
And so, from a way to help influence the good microbes, I can think of two different ways to begin with, but what's your feelings first with probiotics or prebiotics?
Well, probiotics are live microbes that are either in natural foods, fermented foods, or they're as artificial capsules, which you take as supplements, and there's this huge market. And my view is I'm very pro probiotics in real food, because we're adapted to eat them, and we've probably come across them. And so if it's some nice artisan cheese, or it's some yogurt, or some kefir, kimchi, or kombucha, for the kefirs, etc., they're you've got maybe 30 different types of microbe in there. Whereas, and generally, you need a small shot of that every day, and you're fine. That's good for your health. For the probiotics, you're having to select just a few strains of a few microbes, and that's for sort of commercial reasons, these companies have come up with these strains, etc. And it's a bit hit and miss about whether you're going to respond to them or not. Because if everybody's microbiome is different, some people, they might have a negative effect as well as a positive effect. On balance, they tend to be positive. Most of the trials are positive, but they're not consistent in saying which ones work and which don't. In general, they work the sicker you are. But there's some evidence that the sort of what I call the synthetic probiotics can be of some harm. For example, if you take them just after antibiotics, there's some evidence that they slow down how quickly you recover. So it may be that the synthetic probiotics are a bit like the food supplements, that it can maybe overwhelm the system in some people. So it unbalances the community. So I think we have to be a bit careful and not just say all probiotics are great. And definitely we should be promoting real live food, which has been tested for millennia. Mm-hmm. And prebiotics, of course, are again come into these categories of artificial and as part of foods, and they're basically the fertilizers. So these are the foods or chemicals that will enhance your existing gut microbes. And so, in a garden analogy, that they are the fertilizer. And again, in real food, absolutely 100%, that's what we should be eating. Those with high fiber, those with something called polyphenols, which supply energy for the microbes. But every food is in some way a prebiotic. But the synthetic ones, again, a bit hit and miss. You take huge amounts of inulin or some of these other GOSs and FOSs, which they're giving to baby formulas. In general, they work, but we're seeing some rather odd results that sometimes you can overload the system and cause problems. So I think before we start adding them to all processed foods, we just need to be a bit careful and do some better research.
Mm-hmm. And here's a little bit of a different one for you. In this community of listeners, there's a lot of people who follow what's called the carnivore diet. I don't know if you've come across that yet. So what's your initial feelings with that? Because in that community, there's a lot of debates around the fiber discussion. I'd be interested to hear what your opinion is around maybe the sustainability of it, or maybe why people have such a good response sometimes, especially in the first period that they're doing it. I mean, we're in January right now, and there's a lot of people doing what they call the World Carnivore Month. So they just eat meat only for 30 days and to see what happens. I don't know if you have an opinion on maybe the health benefits and why some people respond so well to that.
Yeah, it's interesting. January, people choose to do the World Carnivore Month and Veganuary in the UK, so being vegan. I mean, I think in a way, carnivore diet, a bit like the keto diet, which is where you have to have over 70% fats, is popular in a small group of people, and they do say that yes, they feel great on starting it, and I've had people coming up to me and said, I've been on it for a year and I feel fantastic. Most diets work for a few months, and people often will find a diet that suits them. They feel okay, they can lose weight quickly, and they feel great. I don't think anything should be called a diet unless it is sustainable over years, because anyone can get rid of weight quickly, but if the body compensates and it swings back and you're worse off in a year's time, then really that's an anti-diet. And that's what's true about 99% of these diets. Now, the carnivore diet, I'm largely against. I'm not against it short term, and very happy people try these things. I don't think short term there are particular problems with it, but long term, there's just no diversity in there. And all our studies are showing that food diversity is crucial to have a healthy gut microbiome. And if you don't have a healthy gut microbiome, you've got all these other problems that will ensue, long-term immune problems, greater risk of disease, et cetera, et cetera. So the carnivore diet has probably the benefit of not having any processed foods, a lot less chemicals. So there are some plus sides to it. But unless you can make up for it with a range of other plants to give you that diversity, then I can't see it as sustainable for 99% of the people doing it. Doesn't mean there isn't the occasional person. You know, in the diet myth, I talk about this guy who only for 30 years has only eaten cheese pizza and seems very healthy. So there's always exceptions to these rules, and good luck to them. But I think if I was giving advice, I would say, you know, go for diversity. I don't mind actually people eating meat, and I'm definitely a good thing to avoid processed foods and a lot of these chemicals. But why give up nuts and seeds and healthy plants? And when you see our ancestors, they go for many months in the year without eating any meat. You go to Africa, that's the way they do it. Yeah, meat can be plentiful, but it was never as plentiful as now, where you can buy meat for less than you can buy a pint of beer. It's a different world, and so I don't think we evolved for that, and I don't think long term our gut microbes will like it.
And even what do you think about? I mean, we've both got maybe European genetics, I assume. But if you take someone with European genetics and you put them in Africa, so they're in a different latitude now or a different environment, that's going to influence their microbiome too, right? So I'm just thinking when people listen to this show, but they live in different parts of the world, where they live also makes a big difference as to what foods they might respond to better. Do you think?
I think that's true, yes, because but I mean, some of that is where you live, but also the other part is the diet. So if the standard American diet has gone around the world as it has, and you have that diet, your gut microbes are going to be more similar to Americans than to other people living in perhaps more rural areas where they don't have fast food, etc. So your microbes will follow the food largely, but there are still differences in your gut microbes. And there have been some studies of migrants from Korea and Vietnam to the US, and they do show that they start off with very different microbes, but it becomes more and more like you can't tell the difference from the average US microbiome. So, but we do see different types of microbes in different scenarios in Africa. The same microbe could be having a different function. That's the other weird thing we're seeing. So whether it's a slight strain difference or whatever, but something that's bad in associated with disease in one country could be actually associated with health in another one, because of the diet, because of the environment, because of the dust. So I think we don't have enough data. Most of our data is from Asia and Europe, or European ancestry of America. We don't have that much data from all these other countries comparing rural, urban, and junk food and ethnic food. But yeah, the point is well taken. And that's why giving individual advice about how you can improve this particular microbe is going to vary about which country you're in and what your environment is. And that's going to be tricky. I think we can give generic advice, but the ability to really say, okay, we want to boost this skinny microbe. You need to. This is the diet for you. I think we're a long way from that at the moment, and because also we don't know if they work on their own or they work as communities. The chances are that they could work in slightly different communities in different populations, and so it may be a passenger in one and a driver in the other, because they. The idea you can just put one microbe and sprinkle it on your cornflakes and get skinny, I think is a bit too simplistic. We've got to build up a community, like you would if you just put one animal in the jungle and told him to get on with it. He needs some friends.
Yeah, I can imagine we'll get to that day where we just sprinkle microbes on our food, and voila, it's all solved.
Yeah. No, hopefully we'll live to see that. It'll be fun.
Yeah. Well, Tim, we're coming up on our time here, but I think we've covered a whole bunch of things there. I mean, I could talk to you about topics on this probably for longer, and hopefully when I see you in London, I'll get to ask you a few more questions. But I just want to say thank you so much for enlightening us about everything that's happened over the years and with the current research. And I know we're right on the cutting edge of things, and there's going to be more questions as we find answers, and just saying, hey, have we got the right answers, or how do we're missing all these other pieces. But it's an exciting time to be living in, I think. So again, I want to thank you for sharing that information.
No, it's my pleasure. And if you've got anyone listening in the US who wants to take part in our pilot studies, then go on the joinzoe.com website or search for the Predict study, and exactly the sort of audience, the sort of people who are interested in themselves and individuality that we need to really drive this to the next stage. So it's going to be a fun journey.
So we mentioned your book earlier, Spoon-Fed. That's coming out, I believe, in May. Did you say May 2020?
May the 14th in the UK. Yeah.
Okay, great. So people will be able to.
You can pre-order it already on Amazon. So.
Okay, and if anyone wants to follow you or keep up to the science that you're doing, where's the best places to keep following you or watching what you're up to?
Generally, Twitter. Tim Spector on Twitter is where I do most of the science, and the lighter stuff on Instagram. But so they're the main places.
Okay, perfect. And I'll link to all of that in the show notes. But again, Tim, thank you so much for your time today.
My pleasure.